So today I'm going to show you how I did my MATLAB code just with these surfaces that I have here. Which ones are the middle one? Here. The ones in the middle. Now, here are the surfaces, and I'm going to explain the MATLAB code. Here, the purpose of this is to get clear of all the variables, clear all the command windows, so I can work in a blank space. Now here I have u and v, which are the variables that I'm going to use. I put linspace to put a range to put some like where is going to be from where it's going and from where to where. Here is from 0 to 2 to 60 and 0 to 4 times pi to 200. Now what happens if what would happen if I put 2 pi? Well, it will obviously change. These 60 and 200 are going to represent the points. So you see here, if I put 2 pi, it's going to be like less range that we have. That's why in the original I put it like 2, so we can see more of the more of the figure. Now here I use mesh grid because mesh grid, what it does is make these which are vectors, to turn them into a matrix, right? Because surf needs matrices. X and Y Z will need to be matrices, so that's why I do this, transform the vectors into UV. uh, it it makes them it makes a mesh, and every cell will have a U and a V. That will make it something that the surf will interpret as matrices, and will make the figure as a solid. That's why I didn't use mesh, because here it looks like a solid, right? And in mesh we would have the meshes like the lines intersecting each other, and it wouldn't look like a solid. It makes the illusion that it's a solid, but it's a bunch of lines intersecting together. um, the thing is that it will work well. Will work well if the computer couldn't handle the surf. If it was really big surface that we're making, but in this case not. So it's better to use surf. Now the next things are mainly like aesthetic things. Shading, it makes the colors get a shade. If not, it would be only plain colors. Color map, the color map, and with the Parula makes this thing that when it's in the highest value, it's going to be uh, of one color, and the lowest is going to be another. Yeah, it's pretty useful. I used it because if I only used the plain color, it wouldn't seem like a three-dimensional figure. The color bar here, it's obviously for the color bar. X label, Y label, Z label is for here to see X, Y, and Z. Title for the title, and grid on for graphing the grid. The view tree, it's a predetermined a view in MATLAB that I decided to use because like it kind of gives a good general view. Now we got to do the other surface. Here I use the linspace with T, like we have T here. Yes, because it is function R of T. In the other one it was R of U and V, but now we only have one variable, which is T. uh, the same, one and 200 points. I put 200 points because if I put less points, it would look like really vectorial. Let's see. Let's see how does it look like if I put it like that. It's going to look really bad. And as you can see, okay, I don't know what happened here. Well, the thing is, it wouldn't look as smooth as it should look, right? So I'm going to run this again. Okay, so we have our vector variables here, which is the functions that we have, right? Well, the variables x, y, and z, uh, x, y, and z, right? I'm going to use surf to make this thing that it's in a shade, so that's why I need x, y, and z to be in uh, in not in vector form, but into matrix form. Yes. So I built a two-row matrix, and the top row it's going to be the curve itself, which are going to be the set values. That's why the projection of the floor, which is here on the plot tree, is going to be zeros, and with the size set. All right, so this plot is for plotting what like the projection on x y, right? um, Here, this plot here, it's going to be the curve, which is the red line, and the surf is going to be the colored thing, the colored surface that's underneath the curve. So here we put the vectors. I think, sorry, here we put the vectors, but here we put the matrices. Phase alpha. What basically does is do the transparency. Um, so I put it in 0.4, but if I put it in less, like 0.7, 0.1, it's going to change. Like here, and here we're going to see this how does it change. As you can see, oh well, let's wait a little bit. As you can see, uh, it makes it appear like invisible, right? But let's put it on the value that I had. Now then well, edge color we put none. Uh, but what if we like this is what's going to give us a smooth surface, right? So that's why I put none here. Now here, as well as the other one, labels, titles, this legend here is the one that appears here. So now we shall go to the last one. uh, as the second one here is R of t, so I'm only going to use t. And well, I will use quiver here. What is quiver going to do? Is going to put these arrows along the curve. um, I do vector here, and this which is going to be, as I will show you here, uh, this one and then this one. This fx, fy are going to be the parametric equations that we're going to use, right? So now we've got the figure, state figure, we have to hold on, uh, and then I have the plot. I have the plot here, which is going to use x, y, and z, which is going to be these ones, right? and a line width with a line width of 2, and it's going to be that one. All right. So now that we got here the quiver, I'm going to use IDX. IDX is a function that makes the length of of these arrows, right? So I put quiver, and then I put here these ones with obviously the IDX, and then I put them here. I also do the same with these ones, so it's going to be here the values of the length uh, and the line width, right? And these are going to be all merely labels, um, and that's it, right? um, Now let's see, what if uh, I don't know, what if we change this value? Well, we do have totally different thing, right? So let's see, we're going to put this, and you see how it changes. I'm going to put it, oh yes, here it is. So it goes from 1 to 6 and with the length t, right? I'm going to put it like it was. So that is basically my MATLAB code. That was my explanation. Thank you.